section is hard. The rest of the chapter is easy. All right? Throw in the towel, I don't care. I don't care. You're not going to graduate. So let's buckle down. Here we go. We are ready, 5.1, for number 10. Make sure you have your little colored half sheet. Your little colored half sheet. Everybody got a colored half sheet. We did this a long time ago, remember? We did all that when we started reading. Different colors. Some of you have green, some have purple, some have blue, I don't know. All right, here we go. Here we go. Our job is to simplify this. If you remember, we did a couple problems like this already. And I suggested to you that when it is just something over something, there's not an addition, there's not another part to the problem, it's just thing over thing. I suggested to you that you write it out longhand. So instead of writing it as a fraction, we write it as tangent squared divided by secant squared. And then does anybody happen to remember what we did next? When we did these problems just like this? Huh?
Flip the secant to the other form.
Yeah, actually we're going to do it with tangent too. Tangent, if I look on my colored sheet in my handwriting up here at the corner, it says tangent is sine over cosine. So tangent squared would be same thing, but squared over squared. Sine squared over cosine squared. And then, as Kyle said, secant is 1 over cosine. Now, I just scolded a student this morning. I'm not going to keep telling you that secant is 1 over cosine. That's supposed to be memorized, but if it's not, put it on your sheet. Right? Put it on your sheet. Secant is 1 divided by cosine. So secant squared is 1 divided by cosine squared. Now, what happened last time we did one of these is, at this point, we could actually cancel something. But not this time. Because canceling happens between the top and the bottom, right? So I have 2 cosines, but they're both on the bottom. So they're not going to cancel. They're going to get multiplied together. And I'm going to end up with sine squared over cosine to the 4th. And there really isn't anything else I can do with this problem. Okay, so one of the tricks, and it's not really a trick, but one of the strategies we have is if it's just a thing over another thing, write it out longhand, change them into their fraction form, and, oh, wait a second, guys, wait a second. That was a division, not a times. I left the stuff out, yeah, thanks. You guys are supposed to tell me when I do that. This was sine squared over cosine squared, divided by 1 over cosine squared. What do I do with the divided by? Flip it. So sine squared over cosine squared times, oh, this is better, cosine squared over 1. Flip this one. Now I can cancel. So the answer is just sine squared. Okay, so let me back up to what I was saying when I discovered my mistake. When you have something over something, write it as a longhand division. Then change the things into their fraction form. Everything except sine and cosine has a fraction form. So tangent is sine over cosine. Secant is 1 over cosine. As soon as you get them in their fraction form, then keep, change, flip, and then cancel if you can. And here we can. this, right? Okay, so that's one strategy. Number 11 is another strategy which we talked about, last time when we were doing all of this. I am not going to do this with that problem. Would you agree? It's not the same kind of thing. What do you notice about this problem though? Like I just started almost doing it automatically. What do you notice about it? Each piece has a sign squared, which means I can factor it out. So if I take out a sign squared, factoring, like regular factoring, if I factor out a sign squared, in the first part, I'll be left with secant squared, right? And in the last part, I'll be left with just one. If I take this out and this out, I'll be left with secant squared minus one. Okay. Now, on your colored sheet, I had you box in just certain things, so it's not overwhelming, you're not looking at the whole sheet. You boxed in an identity that says 1 plus tangent squared is secant squared. You box that in. Now, what made me think of that? In this parentheses, I have a secant squared and I have a 1. There's a secant squared and a 1. So I immediately thought about what was on my sheet. Now what do you think I can do now? What can I do here? What? Secant squared minus 1 equals tangent squared. Because if you take that formula that's on your sheet, it's minus 1 from both sides. Isn't this what you get? Move this 1 to the other side. You can write this down on your sheet too if you want. It's just a different form of this one.
Where'd you get the tangent from?
On my green sheet, or I keep calling it green, whatever color it is, you have this written down. And I need to deal with this secant squared minus 1. So I'm going to use the identity that involves secant squared as 1.
So is the tangent replacing the secant minus 1?
Yep.
Or just,
Yep.
So
Yep. So this is going to become tangent squared. Secant squared minus 1 is substituting in or replacing, or tangent squared is replacing that. Secant squared minus 1 is the same as tangent squared. So when you see a secant squared minus 1, you can automatically replace it with a tangent squared. Because that's what it is. It is that. Now, this is a times problem. This is just sine squared over 1. I can't do anything with that. What is tangent? According to your sheet, what can you do with tangent? Sine squared over cosine squared. Now, why am I doing this? Because ideally, in a multiplication problem, what will happen? This is a multiply problem. In a multiply problem, what will happen? Things will cancel. Not this time. This time it really is sine to the 4th over cosine squared. Nothing's going to cancel, but that's my goal always, is to cancel if I can. So once I get it down to a times problem, I'm going to change those into their fraction form and hopefully be able to do this. So that's my answer. practicing. All right, let's look at the next one. We talked about this one also. I want you to look at it very carefully. And I want us to agree, we aren't going to cancel right now. We can't cancel right now because of these. When there are pluses and minuses, you either cancel out the whole thing or you don't cancel. You can't cancel out parts of it. In a times problem, you can cancel whatever, but not if there are adds and subtracts. So if you think you're going to be able to cancel here, you're wrong. You can't. There is something you can do though. Look at that numerator. We talked about it the other day.
I forget what it's called, but can't you split it into plus 2 minus 2?
Exactly. It's called the difference of squares. We're factoring the difference of squares. And we really don't have to remember the name of it, Lena. We have to remember what to do. And you did. So the top is going to factor in cosine plus 2 and cosine minus 2. You cannot do that with the denominator because it's not squared. So the denominator is just going to stay the same. But what is the glorious good news here?
You can cancel.
These whole things, not pieces of them, the entire thing is canceling. And so the answer is just cosine plus 2. All right, let's look at the next one. Someone can be writing this. Yes, hold on. All right. Repeated, not command, persona. Okay. All right, we have done a problem like this a couple minutes ago. In fact, I just erased it. It was when I erased to put this one up. There is something special about that. Can anybody tell me? So we know from our sheet that sine squared plus cosine squared is 1, right? If I move this over to the other side, if I minus this over to the other side, what will that equation say? Minus this over here, what will it say? Cosine squared equals 1 minus sine squared? Write that down on your paper if you haven't already. It's fine. It's another version of that. And what does that mean? That means every time you see a 1 minus sine squared, you can replace it with cosine squared. So I'm going to, here's my secant squared, and I'm going to replace that with cosine squared. Every time you see 1 minus sine squared, you can make that a cosine squared. What do you think about 1 minus cosine squared? Sine squared. Now that's a times problem. What did I suggest? What did I suggest to you in a times problem? Change them into their fraction form. So what's secant? 1 over cosine, good, but it'll be squared because that's squared. Sine and cosine do not have alternative fraction forms. Sine and cosine are just sine and cosine. Oh my goodness, what's gonna happen?
Yep.
The whole shebang is gonna cancel, so the answer to that problem is 1. can change them into X's or something. Don't let that bother you. Give me an idea, we gotta do something. What's your idea? So we could absolutely change all of these into their fraction form if you want to. So cosecant is
1 over sine.
1 over sine, very good. Tangent is
Sine over cosine.
sine over cosine. And then secant is
1 over cosine.
1 over cosine. So far, so good? Now be careful. See that plus sign right there? That means I'm not going to be able to cancel anything over here, but these two are multiplied. Can I cancel here and these two? Yep. And that's going to leave me with 1 over cosine. And then I have plus another 1 over cosine. That's 2 over, they already have a common denominator, so I'm gonna add them. So that's 2 over cosine. I would let that go for full credit, but that's 2 times 1 over cosine, so it's really 2 secant. That would be the best answer, but because there's 2 in that numerator, I would let that go with a 2 over cosine. The 2 secant would be the best answer. That's a secant and that's a secant, so I have 2 secants. That's my answer. All right. Next one. There are a couple of different ways we can go with this problem. What is the relationship between sine and cosecant? How are they related to each other? What? Cosecant is 1 over sine, isn't it? So what happens, this is a multiply, you guys. What happens when I multiply sine squared times 1 over sine squared? This is the reciprocal of sine. What happens when I multiply those? They cancel and I just get 1. Right, don't these two cancel? So these make a 1. Anytime you multiply reciprocals, think about it. 3/5 times 5/3. When you multiply reciprocals, don't they cancel? These are reciprocals of each other. So when they multiply, they're just gonna make a 1. So now this is 1 minus sine squared. Well, that's on your paper, or should be, and if it's not on your paper, because you didn't write it down, then it better be up here. What's 1 minus sine squared? Cosine squared. The answer to the problem is cosine squared. 1 minus sine squared is the same as cosine squared. Every time you see a 1 minus sine squared, you're going to change it into almost every time, you're going to change it into cosine squared.
Is it the same for 1 minus
Yep.
cosine?
Yep, 1 minus cosine squared is sine squared. Oh boy, let's look at number 16. Everybody in the room should know how to start this one. Everybody should know. Look at it. It's a big old parentheses squared. What does that mean? Parentheses times parentheses. So we're going to FOIL. This is sine plus cosine times sine plus cosine. That's what a parenthesis parentheses squared means. Always. Right? It means times itself. So here we go. Sine times sine is sine squared. Outsides, I'm foiling, sine times cosine. Sine times cosine is nothing special. It's just sine times cosine. They only cancel when they're reciprocals of each other. All right, so what's on the inside? Cosine times sine. And what's at the end? Cosine squared? Foiling is foiling just like regular. So first times first, outside's inside last. Now, do you notice anything about what we have left? Notice anything? The middle, now the middle doesn't cancel, Trey, because they're both positive. If one were negative, they would cancel. But since they're both positive, I have two of those. So I'm gonna have two sine cosine. One of them and one of them makes two of them. There's no negatives in this problem, but if this one had been a minus, then they would cancel. But as it is, they're like quantities. I add them together. Yes,
You
Kyle?
make the sine and cosine one.
Exactly. Sine squared plus cosine squared is 1. So this one boils down to 1 plus 2 sine cosine. This is actually a formula for something else that we're not doing. It's on the read sheet, and I see it, but we're not doing it, so we're stopping right here. We're not using those other formulas. All right, good job. One more. Cotangent minus cosecant times cotangent plus cosecant. Well, what do you suggest? Well, so first times first. Now, outsides are going to be positive cotangent cosecant. Right? And then insides are going to be negative cosecant cotangent. And then lasts will be minus cosecant squared. You need to be able to foil. Does everybody follow that? First, outside, inside, last. And this one does have some negatives in it. So there's a possibility things will cancel. What do you think? Aren't these two the same? Remember, you can multiply them in either order. X times y is the same as y times x. So those are the same thing, and they cancel. One's positive and one's negative. So I'm left with cotangent squared minus cosecant squared. I see Trick looking at his purple sheet. We all should be looking at our purple sheet. What does our purple sheet say? Relative to these guys, what does it say? 1 plus cotangent squared is cosecant squared. So on our paper it says 1 plus cotangent squared is cosecant squared. So what do you want to do? Could we take this out and replace it with this? Alright, so it's going to be cotangent squared minus 1 plus cotangent squared. this guy right here, this cosecant squared, I'm replacing with what it says on my paper, 1 plus cotangent squared. Okay? Now, what do you think I should do now? Distribute the negative? I would hang on to it for a minute. Let's distribute the negative. Now, do you notice anything? Yeah. Doesn't that cancel with that? Aren't they, isn't that cotangent minus cotangent? So what's the answer to the question? The whole thing boiled down to. Now, your mind is blown.
Doesn't matter which one you would have picked, right? Which one we would have picked there, so instead of doing the 1 plus cotangent,
Yes. You get the answer. Okay.
I've been defeated.
Hey, that shit I said about Kyle. That shit I said about trying we applied to chapter 4, dog. Chapter 5, we still cook. I don't even know what to lock in on.
Now, just to show you that these don't have to be incredibly difficult, we're gonna do practice quiz 1 right now. We'll be having a quiz next week. Yeah, because today's Wednesday, yeah. But we're gonna do practice quiz 1 now because I want you to see that you have learned something and you are better at this than you were initially, and you do not need to play. So let's look at practice quiz 1. And you are looking at the first problem and you're thinking, oh my gosh, she expects me to do this? Yes, I do. And this is easy. So let's look at it for a second. Notice, boys and girls, it is all multiplied. The whole shebang. What do I do when my problem is all multiplied? What is one strategy? Change them into their fractions and hopefully cancel. Now remember, cosine and sine do not have fractions. They don't have any alternative. They're the building blocks. So we're going to start cosine over 1. Now, what about this one though? What is tangent? So it'll be squared, sine squared over cosine squared. Sine does not have a fraction. Sine and cosine do not have a fraction. What about cosecant? What's cosecant? 1 over sine, and it will be squared because it's squared. And then what about cotangent? Well, don't do 1 over tangent, do it in sines and cosines. It is 1 over tangent, but that won't help me. If tangent is sine over cosine, then cotangent is cosine over sine. I would write that down if I can't remember it. I'll write it down on paper. Cotangent is cosine over sine. It's the reciprocal of the tangent. And my whole goal here is to make things cancel. So I don't want to write 1 over tangent because that isn't going to cancel. So I want to go cosine over sine. Does that make sense to you? Okay. All right. All multiplied. Anything on the top cancels with anything on the bottom, anywhere in the whole problem. So, let's see. I got a sine squared and a sine squared. can do this in any order, I'm just looking at what's there. I got a sine and a sine. Now, don't I have two cosines on the top and two on the bottom? So boom, boom, boom,
Oh,
and what's left? One. So that whole mess boiled down to just one. You can do a problem like this. And when we take our quiz next week, it will have a problem like this on it.
do we get something like this?
You get that if you take it on time. I'm done with all this late stuff. So be here on quiz day, you get it. Not here on quiz day, then you don't. You gotta memorize. Okay? Now, the second one, okay, so everybody okay with this? Easy. The second one is not the same kind of problem. The second one requires us to look at those other formulas on our sheet. Okay, does everyone recognize this is a different kind of problem? So we aren't going to do it the same way we did the last one. So I want you to look at that numerator right there. Is there anything related to that on your reference sheet? What is related to that? 1 plus tangent squared is secant squared? Right? So if 1 plus tangent squared is secant squared, can I take this out and replace it with this?
Yeah.
So what would it look like? 1 plus tangent squared minus tangent squared, cell over cosine. So I looked at my numerator, said, okay, there's something on my sheet that kind of goes with that. It's this one. Every time I see a secant squared, I can replace it with 1 plus tangent squared. So that's what I did. Now what happens? These are gone, and what am I left with? 1 over cosine, which everybody in the world knows is secant. That should be written on your paper. If it's not, get it memorized. You gotta know it. 1 over cosine is the secant. Now, a few days ago, you were feeling totally overwhelmed. And maybe you still can't do these totally by yourself, but they make a little bit of sense now. You see, oh yeah, with some practice, I'm gonna get this. All right, hang on to that quiz packet. We will do more of that and some additional practice. But I want to expose you to the next part of the chapter, which this is really easy. You're going to like this. It's easy, easy, easy. We are going to solve I am not assigning the homework just yet because I want to do some of it with you in class. So next time I'll do some of the 5-1 homework with you. Okay? Not all of it, but some of it. Okay, so here is a triangle. And I have labeled the stuff that they gave me to label. Our job is going to be to solve this triangle. Now, what does that mean? That means I'm going to find, you're going to find all of the missing pieces. Okay? Now, before we start, we got to get something understood. When we label a triangle, we use capital letters for the angles. So this is angle A, this is angle B, this is angle C, and I use capital letters. The sides across from the letters, we call it the opposite side, across from the angles, those are small letters. So this is side A because it's across from angle A. This is side B and this is side C. So capital letters always refer to the angles, and then the small letters refer to the corresponding side. And by corresponding side, I mean across from it. Okay, got it? That's A, that's B, that's C. You found sides and angles on the test you just took. Think of the eagle on top of the building and the worm on the ground and all that stuff. But every time you did one of those, you had a right triangle, right? You had a right triangle. And so we could do SOHCAHTOA, opposite over hypotenuse and all that stuff. Can't do that in this triangle because this is not a right triangle. Luckily for us, there's a handy dandy law. It's called the law of sines. Write it down. We're not gonna have time to even use it today, but write it down. The law of sines says in every triangle in the whole wide world, the sine of angle A over side A, that fraction, sine of angle A over side A, equals sine B over B equals sine C over C. So the law of sines is just a proportion. So in this problem, can you see how we can start setting up the law of sines? Look right here. Can't I say sine 38 over 16? What am I going to set that equal to? Sine 70 over, see? And I'm going to stop right there. I'm going to cross multiply, divide, and get my answer. It's going to be that easy, okay? But we don't have time to do that. Every single problem in 5.5 and 5.6 requires your grapher, so make sure you got it. Every problem, every single one in 5.5 and 5.6 is going to require us to have our graphing calculator. Our graphing calculator will be set in degrees because all of our triangles are going to be in